we are asked to identify the degree, leading term, and leading coefficient of the following polynomial functions. We identify the highest power of the variable to determine the degree. We identify the term containing the highest power of the variable to find the leading term. And finally, we identify the coefficient of the leading term to find the leading coefficient. So for number 1, we're given the function f of x equals 4 minus 3x squared minus 5x to the third. Let's begin by determining the degree of each term. The first term is 4. Any constant term has degree 0. The second term is negative 3x squared, which has degree 2, given by the exponent of 2 on the variable x. The third term is negative 5x cubed, which has degree 3, given by the exponent of 3 on the variable x. So because the highest power on the variable is 3, this is a degree 3 polynomial function. And because the term containing the highest power on the variable is negative 5x cubed is the leading term. The coefficient of the leading term is negative 5, and therefore the leading coefficient is negative 5. Now I do want to mention one more thing. Often a polynomial is given in descending order, which means the terms are listed from highest degree to lowest degree. If we were to write f of x in descending order, we would have f of x equals negative 5x cubed minus 3x squared plus 4. One nice thing about having a polynomial in descending order is that we can determine the degree, the leading term, and the leading coefficient from the first term of the polynomial function, again as long as it's in descending order. Number 2, we're given g of t equals 1/2 t to the 6th minus t to the 4th plus 3t squared minus 1. Let's begin by determining the degree of each term. The degree of the first term is 6 because of the exponent of 6 on the variable t. The degree of the second term is 4 given by the exponent of 4 on the variable t. The degree of the third term is 2. The degree of the last term is 0. Because the highest power on the variable is 6, this is a degree 6 polynomial function. And because the term containing the highest power on the variable is 1/2 t to the 6th, the term 1/2 t to the 6th is the leading term. And because the coefficient of the leading term is 1/2, the leading coefficient is 1/2. Notice this time g of t was given to us in descending order. Number 3, we have h of s equals s, or if we want s to the first, minus s to the 4th minus 5. The degree of the first term is 1, given by the exponent of 1 on the variable s. The degree of the second term is 4, given by the exponent of 4 on the s. And the degree of the constant term, negative 5, is 0. Because the highest power on the variable is 4, this is a degree 4 polynomial function. Because the term containing the highest power of the variable is negative s to the 4th, negative s to the 4th is the leading term. Notice how we have a negative here because of the minus s to the 4th. Remember, minus s to the 4th is the same as plus negative s to the 4th. And because negative s to the 4th is equal to negative 1s to the 4th, the coefficient of the leading term is negative 1, which means the leading coefficient is negative 1. So while we are done, let's go ahead and give h of s in descending order. In descending order, h of s is equal to negative s to the 4th plus s minus 5. I hope you found this helpful.